Alright, question G asks us to review the last three answers here. Let's read. What do you notice about your answers in parts E and F, that's these two, slope and vertical intercept, and the formula you wrote in part D, that's that guy. So what do you notice about the formula that relates D and P, and then your slope and your vertical intercept? Well, let me summarize this. Here is our answer to part D. That's our formula that relates these two. Here we know the slope is that, and then the vertical intercept is that. What do you notice? And hopefully you are having an all-like moment and saying, well, look at the slopes there with the operation in front being the sine, and there's the second half of the vertical intercept. And what we have here is a linear function between these two. So here's the question. A natural question is, will our symbolic rule between linear functions always have the slope identified and the vertical intercept identified? And that, my friends, is an absolute yes. So let me give you some general terms. So again, this is the slope and the second half of the vertical intercept. The slope here being attached to the input variable with the operation or the sign out front included. So here's some generalities you're going to read. If x is the input variable and y the output, and y is a linear function of x, meaning this is a linear function of that, then the symbolic rule, I guess I should have written that, is written as this. The output variable equaling the input variable with the slope attached to it as the coefficient, and then the constant term without the variable is actually the second half of your vertical intercept. Now this is not written like this, it's more written like this. The constant term being out front here and the variable term being second. And by the way, this could be a subtraction, that could be a subtraction, and that could be a negative, that could be a negative as well. But this is the general idea that every linear function can be written this way, its symbolic rule anyway, with the slope being attached to the input variable and then the constant term being part of the vertical intercept, namely the second half. The first half will always be 0 there. So hopefully that brings some enlightenment to you, but we're going to use this. This has a special name, this form here, and let's go back to page 1 and fill in this blank. A symbolic rule for any linear function can be written in a special form where the slope and the vertical intercept are part of the rule. This special form is called the slope-intercept form of the relationship between the two variables. So this, my friends, is what we call in slope-intercept form. Why? Because the slope is sticking out like a sore thumb, and so is the second part of the vertical intercept. So this whole section is on the slope of the slope-intercept form, and so we're going to show you some more examples on how to use that.